let's spend a few minutes taking a look at how to solve equations. So solving equations are one of those kind of main skills that we need that follow us all throughout our mathematics history and heading into the future math courses. So we're going to just kind of remind ourselves of the rules around solving equations. Okay, well, let's begin with just the basics. And so if you think about solving the equations as doing the opposite operations as BEDMAS, order of operations, then you should be okay. So BEDMAS always starts with brackets, then exponents, division, multiplication, addition, and subtraction. And when we solve equations, we actually kind of go in the opposite order of that. So I'm looking to see if anything's being added or subtracted to my x variable. And I can see right here I have this -5. So I'm going to start by doing the opposite operation, which is +5 to each side. That leaves me with a 7x. And then we have -5 plus 5, which is 0. So that's gone. And then we have 37 plus 5, which is 42. From there, I can divide then by that 7 in front. So if I divide each side by 7, I get 7 divided by 7, which is x, just 1x. 42 divided by 7, which is 6. So that means my answer must be x equals 6. Of course, you can always do a check. So that's what I absolutely love about solving equations, is that I can always check my work to make sure that I am correct. All I would do is go back to my original equation. Wherever there is an x, I would put it in a 6. So 7 times 6, which is 42, minus 5 equals 37. And I can see that I get 37 equals 37. So that I am correct. If you have time, I always recommend doing a check. I think it's quite important to make sure that you are kind of doing things correctly. So that's a great way to do it. Okay, let's try another one here. In this case, I have 13 is equal to 6x plus 6. Again, I'm looking for what's being added or subtracted directly to my x, which is this plus 6. So let's subtract 6 from each side. 13 minus 6, of course, is 7. And then we can divide each side by 3. And that will eliminate the 3 in front of the x, and I get x is equal to 7/3, which is the same thing as saying it as x equals 7/3 this way. So that's the same, by the way. Okay, again, you could check by putting this back into your equation and making sure that it works. If I showed you right here, if I did a little bit of a check, I would have 13 equals 3 times 7/3 plus 6. So 13 is equal to 21 over 3 plus 6. 13 equals, whoops, I kind of made a mess there. Let me just, 13 equals, 21 divided by 3 is 7 plus 6. So 13 equals 13. So we can see that our check worked in that case and gave us the exact same answer. Even with fractions, we can do a check. So don't think because there's fractions that we can't. All right, last one here. I have this 4 out front. Now, even though there's a negative sign between the 4 and the 5, that negative is attached to that -5x. That's over there. The 4 itself is actually positive. So to eliminate that 4, I'm going to subtract 4 from both sides. And I get -5x equals -36 minus 4, which is -40. And then I would divide each side by -5. And -40 divided by -5 is 8. Okay, and again, you can do a check just to see. So 4 minus 5 times 8 equals -36. 4 minus 40 equals -36, and that is a true statement. -36 equals -36. Okay, so remember, as you're solving equations, it's kind of the opposite order of BEDMAS. You're going to look to see what's added or subtracted first and get rid of that. And then you'll divide by whatever number is in front of your x variable. But let's try something a little bit more complicated. So what if there's variables on both sides? So if there's variables on both sides, we actually want to start by moving all the variables onto one side and all the constants, that means a number that doesn't have a variable, on the other side. So this 2x, I would want to move that over on this side by subtracting 2x, by doing the opposite operation. So 5x minus 2x is 3x. This 2x minus 2x is gone, leaving me with just a 12. And now I would add 6 to each side to get rid of that negative 6. So I get 3x equals 18. Divide by 3, divide by 3, and x equals 6. So not a big deal if you have variables on both sides. It's just a matter of moving all the variables onto one side, all the constants on the other side, and then it's just a simple little division that you're going to do. Okay, so let's try another one. And feel free to pause the video and give this one a try and then come back. All right, so if I was going to move this, and I can see I have a 4x over here and an 11x over here. Now, it doesn't matter if I bring the 11x over here or the 4x over there. It's kind of the same thing anyways. So I'm going to actually bring the 4x onto the other side just to show you that it's the same. I'm going to subtract 4x from each side because 4x minus 4x is just 0, leaving me with a negative 9. And then positive 11x minus 4x is 7x. And then I'm going to add 3, and I'm going to add 3 to get rid of that negative 3. So negative 9 plus 3 is negative 6 equals 7x. Divide by 7, divide by 7, and x equals negative 6/7. Again, we definitely can get fractions as answers, so don't be overly concerned when that happens. And if you want, you could always go back and do a check to make sure that your answer is right. Okay, oh, this one's even easier. So I see I have this negative 2x on the left side and a 3x on the right side. So let's actually add 2x and add 2x to the left and the right. That will leave the 7 here by itself. And then 3x plus 2x is 5x. And then now, of course, our last step, divide by 5, divide by 5. And x equals 7/5. And the last one, D. Okay. Oh, this one's a little bit interesting. We have a 2x and a 2x, so I guess it doesn't matter which one we move. So how about I subtract 2x on this side, subtract 2x on this side, and 2x minus 2x, I get 0, so that cancels, leaving me with just a 4, and 2x minus 2x, that just cancels, leaving me with a negative 3, and then I get this very strange equation. I get 4 equals negative 3, which we know is not true. This is false. This is a false statement. And so what this means, when you end up with a false statement like this, it means that these two equations have no solution. So that can happen too, where there's no solution. If you end up with something crazy like this, where you get a false statement, that just means there's absolutely no solution going on. All right. So variables with both sides, just a matter of moving things over to the left or to the right to get all your variables on one side, all your constants on the other. And then from there, you just simplify by dividing whatever number's in front of your x. Oh no, brackets. Okay, so brackets, there's actually a couple of different ways that these can be solved. If you have a number outside one set of brackets like this, you could divide each side. But I'm actually going to, just because it depends on kind of the equation you're given, let's instead get rid of our brackets first. So we know from our distributive property, we're going to take what's outside our brackets, multiply it by what's in. So 3 times 2x is 6x. 3 times negative 3 is negative 9 equals 18. And now we have an equation that we're used to, that we know how to solve. I'm going to add 9 to each side. 6x equals 27. Divide by 6, divide by 6. And x equals 27 over 6. Or I can divide those both by 3. 9 over 2. Okay. Same thing here. I mean, I know brackets, oh no. In fact, we have 2 brackets, but that's okay. We're going to take what's outside, multiply it by what's inside. So 4 times x, which is 4x. 4 times negative 5, which is negative 20, plus 2. equals 3 times x, which is 3x. 3 times -1, which is -3. So let's clean this up. -20 plus 2 is a -18. So now it's just like our other questions where we had variables on both sides. So I'll subtract 3x from here and from here from both sides, leaving me with x minus 18 equals -3. And then I'm going to add 18 and add 18. So x equals 15. So brackets, I mean, are not a huge deal. We're just going to take our time, use our distributive property to get rid of them, and then we just follow all the same rules that we've been doing before. Now, fractions, on the other hand, they can provide a headache at some time. So let's take a look at this. So this has the whole thing's divided by 5. So if we do the opposite operation of dividing by 5, we know the opposite operation of dividing by 5 is multiplying by 5. So I would put brackets around this whole thing, and I would multiply by 5. But if I multiply by 5, I have to multiply by 5 to the other side too. What you do to one side, you have to do to the other. Now, what happens is this 5 divided by 5 right here, those cancel out, leaving me with just 3x minus 2 on my left-hand side, and then 4 times 5, which is 20. And now we just have an equation that we can solve. So whenever you have fractions, you want to get rid of those fractions, and usually it can be done through multiplication. But remember, you have to multiply both sides. So let's add 2, 3x equals 22, divide by 3, and x is equal to 22 over 3. All right, let's try another one. So here we have another one. Okay, so what you may notice now is that we have like these two different denominators where we only had one denominator here, so we just multiplied by 5. What you want to do is you actually want to multiply by your common denominator. So we're going to think of the lowest common multiple again between 5 and 10. And the lowest common multiple between 5 and 10 is going to be 10, right? So I'm actually going to multiply this side by 10, and I'm going to multiply this side by 10, okay? And what happens is 10 divided by, or 5 goes into 10. 10 divided by 5 goes in 2 times. So that leaves me a 2 up there. So I have a 2 and then a bracket and a 2x plus 1. And this 10 can divide into this 10, leaving me with 1, and 3 times 1, which is just 3. So now we end up with an equation like this, which again is just perfectly fine. I'm going to multiply this 2 inside the bracket. So 4x plus 2 equals 3. And then I'll subtract 2 from each side. 3 minus 2 is 1. And then divide by 4, So x equals 1/4. So this one was a little bit harder. We had 2 denominators now. So I just found the lowest common multiple and then multiplied each side by that lowest common multiple. From there, I could reduce it down because 10 divided by 5 is just 2. So that becomes a 2 in my numerator. And then the 10 divided by 10 over here became a 1. And I was able to just use my distributive property in order to expand this, get rid of my brackets, and then solve the equation. Okay, so same thing here. We have, what do we have here? We have 4 and a 3. So my lowest common multiple between 4 and 3 is going to be 12. So I'm going to bracket this whole thing and put a 12. And bracket this whole thing and put a 12. And then we're going to think about this. 12 divided by 4 is 3. And 12 divided by 3 is 4. And what this gives me is 3 bracket 6x minus 2 equals, and then I have a 4 bracket 3 plus 2x. Okay, so still going to be a big question, but we've gotten rid of our fractions, which is awesome. I'm going to take a moment, multiply what's outside my brackets by what's inside my brackets. So 3 times 6 is 18x. 3 times -2 is -6. 4 times 3 is 12. 4 times plus 2x is 8x. And then from here, I'm going to move all my x's onto one side. So I'm going to subtract 8x to both sides. 10x minus 6 equals 12. Add 6. Add 6. 10x equals 18. Then divide by 10. Divide by 10. So x is equal to 18 over 10. That can reduce down to a 9 over 5. I can divide both these by 2, which would give me 9 over 5. Okay, so that was definitely like a little bit harder, right? Because we found our common denominator, but it didn't totally cancel out. It still left us with a number out front of our brackets. Then we had to multiply those in, and then once we multiplied those in, we had to put all our variables on one side and solve. So that was definitely a bigger question. All right, well, we're almost to the end, but let's ramp this up just a little bit more and do something totally crazy. Oh man. So we need a common denominator between 4, 5, and 6. 4, 5, and 6. My common denominator between 4, 5, and 6 is going to be, I think it's going to be 60. I feel like 60 is my lowest common multiple. I'm going to use 60. And so what I want you to see is I got to multiply this by 60. I got to multiply this by 60. I got to multiply this 3 by 60. And I have to multiply this last by 60. So everything gets multiplied by 60. Nobody gets left out. And that's what's really most important to realize when you have these fraction equations, is that when we multiply through, every single term gets multiplied through by that number. Okay, so 60 divided by 4 is going to give me 15. And 60 divided by 5 is going to give me 12. And 60 times 3 is just going to be 60 times 3. There's no denominator there, so that's going to stay as a 60. And then 60 divided by 6 is going to give me 10. And what I end up with is 15 times 3x plus 12 times 7 minus 2x equals 60 times 3, which is 180, plus 10 times 4x minus 1. All right, so we're going to start doing some multiplication here and some distributive property. Can't be helped. It's got to be done. So 15 times 3x is 45x. 12 times 7 is going to be 84. 12 times negative 2x is going to be negative 24x. 180 plus 10 times 4x is 40x. 10 times negative 1 is minus 10. Okay, so 45 minus 24 is going to be 21x plus 84. And then 40x and 180 minus 10 is going to be 170. Whew. All right, so let's subtract 21x from each side. So that goes, leaving me with 84 equals 19x plus 170. And then I'm going to subtract 170 from each side. And this I'm going to actually pick up a calculator for. So 170, 84 minus 170. And I did not get a right answer there. 84 minus 170 equals negative 86 equals 19x. Okay, and now I'll divide by 19 and divide by 19, and x is going to be a negative, and 19 is prime, so let's see if that, no, it doesn't divide evenly. So negative 86 over 19, we'll just keep it like that. Wow, what a huge question. And so many places we could make mistakes, but we got through it. So remember, find your lowest common multiple, multiply through by every single term. Even the little constants, they get multiplied by that denominator too. And then from there, simplify. And you're going to have to use your distributive property and then collect like terms and then put all your variables on one side and all your constants on the other side and then divide. All right, so obviously this was a whole bunch and needs some practice. If you have any problems at all, please come back to me and ask for help. I'd be more than willing to help you out.